Using TF-IDF to vectorize text can be a stronger approach than the bag of words model because it keeps more of the context behind each word. TF-IDF stands for term frequency inverse document frequency. In simple terms, it measures how important a word is within a collection of texts. It does this by looking at two things: how often the word appears in a single document and how common it is across all documents. Before we break down how TF-IDF is calculated, let's first define the two parts separately: term frequency and inverse document frequency. Term frequency refers to how many times a word appears in a single document. Here, a document means one piece of text, such as a row in your dataset or an item in a list. This gives us a relative frequency. In other words, how important that word is within that specific document. Inverse document frequency, or IDF, looks at the bigger picture. Instead of looking inside just one document, it looks across the entire collection of documents. Once calculated, common words will have a lower score because even though they appear often, they don't help distinguish one document from another. Less common words will have a higher score because they carry more weight in showing what a specific document is about. This helps retain context about how words are used and which words are important to specific documents and to the dataset overall. Thankfully, the sklearn package provides a TF-IDF vectorizer that performs these calculations automatically. So let's import it from the sklearn feature extraction text module. What follows is pretty much the same as what we did with our bag of words. First, we initialize the vectorizer and store it in a separate variable. Then we do the fit transform and reference our data. Next, we create our data frame and use the TF-IDF vec fit, converted to an array, which can go into a table. Finally, we collect the column names using the get feature out method. Let's print this out. Instead of just ones and zeros, we now see a range of numbers. Each number reflects how important a word is in a specific document. Thus, the TF-IDF representation keeps more of the context. It captures not only whether a word appears, but also how it is used differently across documents. As a result, when we apply machine learning, we give our models more nuance to work with, helping them better understand patterns in the text.